Similar triangles. Exercise 8.4. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of its diagonals. This is a rhombus. A, B, C, D. Diagonals are A, C and B, D. These two are diagonals. We have to prove that the sum of squares of the sum of squares of the sides of a rhombus is equal to the squares of diagonals. For example, we know that it's a in right angle triangle, it's a hypotenuse with respect to the Pythagoras theorem. If you apply, we can understand. Now look this, that given ABCD is a rhombus. ABCD is a rhombus. Let its diagonals AC and BD are diagonals. Bisects each other at point O. Bisects each other at point O. Point O. We know that the diagonals in a rhombus are perpendicular to each other. AC and BD are perpendicular to each other. AC is perpendicular to BD. Then from AOD triangle, it's a right angle triangle. So we can write with respect to Pythagoras theorem, AD square is equal to OA square. AD square is equal to OA square plus OD square. Pythagoras theorem applied here. AD square is equal to OA square plus OD square. From COD triangle, it is also right angle triangle. We can write CD square is equal to OC square plus OD square. OC square plus OD square. From BOC triangle, BC square is equal to OB square plus OC square. From AOB triangle, AB square is equal to OB square plus OA square. AD square is equal to OA square plus OD square. CD square is equal to OC square plus OD square. BC square is equal to OB square plus OC square. AB square is equal to OB square plus OA square. Now, so this is from AOD, AD square equal to OA square plus OD square, and COD, CD square is equal to OC square plus OD square. This is number 2, 1. And OAB, triangle OAB, AB square is equal to OA square plus OB square. This is number 3. From triangle BOC, BC square equal to OB square plus OC square. By adding all these, AB square, AD square plus CD square plus AB square plus BC square is equal to OA square plus OD square, OC square plus OD square, OA square plus OB square plus OB square plus OC square. Then that equal to AD square plus CD square plus AB square plus BC square is equal to 2 into OA square plus OB square plus OC square plus OD square. we know that OA is half of AC. OA is half of AC. OA is equal to AC by 2 and OC is equal to OC, and OD is equal to BD by 2, that equal to OB also. From this, OA is AC by 2, OB is BD by 2, and OC is AC by 2, OD is BD by 2. Half of AC is called OA, half of BD is OB, half of AC is OC, and half of BD is OD. From this, then, but OA is equal to OC equal to 1 by 2 AC, BO is equal to OD is equal to 1 by 2 BD. OA is equal to AC by 2 is equal to OC, OD is equal to OB, BD by 2. Now squaring, 2 is 2 and 1 by 2 is 1 by 4, AC is AC square, 1 by 2 is 1 by 4 and BD is BD square. Here is also BD square by 4, BD square by 4, AC square by 4 and BD square by 4. But AC square and denominator is 4, taking LCM, 4 taking LCM, AC square plus AC square by 4 and BD square plus BD square by 4. AC square plus AC square is 2 AC square by 2 AC square and 2 BD square by 4. Now this equal to, if you multiply with 2, 2 into 2 4, 4 4 cancel, and 2 into 2 4, this 4 4 will be cancelled, where AC square plus BD square. This equal to AC square plus BD square. We require to prove that all sides sum of square of all the sides of rhombus, this is AD square plus CD square plus AB square and again BC square is equal to diagonals square. What is diagonal? AC square plus BD square. Hence it is proved that equal to AC square plus BD square. All sum of the squares of the sides is, that is AD square plus AD square plus CD square plus AB square plus BC square is equal to AC square plus BD square. Question number 2. ABCD is a right angle triangle and right angle at B. Let D and E are the points on AB and BC respectively. Now prove that AE square plus CD square is equal to AC square plus DE square. What is given? In triangle ABC, B is right angle 90 degrees and DE are the points on AB and BC. Now required to prove AE square plus CD square is equal to AC square plus DE square. And prove in triangle ABCD is a right triangle right angled at B. AB, BCD, BCD, this one BCD is a right angle triangle at B. But we know that BD square plus BC square is equal to, we can write CD square. What is that? BD square plus BD square plus BC square is equal to CD square, because here is the right angle, CD is a hypotenuse. Next, also from this ABE triangle, it is also right angle at B. We can write AB square plus BE square is equal to AC square. AB square plus BE square is equal to AC square. This is number 2. From 1 and 2, if you add these two, AB square plus BE square and BD square plus BC square is equal to AC square plus CD square. Okay. From 1 and 2, this is 2, AB square plus BE square equal AB square. Then BD square plus BC square plus AB square plus BE square is equal to CD square plus AE square. We are adding 2, 1 and 2. One is BD square plus BC square is equal to CD square. 2 is AB square plus BE square is equal to AE square. Therefore, this equal to BD plus BE, BD plus BD plus BE, BD square and BE square, BC square plus AB square. Now observe this triangle. What is that? BE square plus BD square is equal to, we can write DE square. What is that? BE square plus BD square is equal to DE square. Okay. And BC square plus BA square, AB square is equal to AC square. Observe this. BD square plus BE square is equal to DE square, and AB square plus BC square is equal to AC square. So then this is equal to CD square plus AE square. Hence it is proved. Prove that 3 times the square of any side of an equilateral triangle is equal to 4 times the square of the altitude. Now, given ABC is a triangle, an equilateral triangle. Equilateral means 3 sides are equal sides. And the altitude AD, this is altitude A, B, C, AD, this is altitude. And the side is unit, altitude is H units. For example, this side is A units, that H is altitude. Then we require to prove that 3A square, 3 into side square is equal to 4 into H square, 4 into altitude square. Now, this is ABC triangle, ABC triangle. The altitude is AD, that is H. Now the side is A. In triangle ABD, ABD and ACD, these two triangles are, but we know that angle B is equal to angle C. Why? Because this is a equilateral triangle. Equilateral means all the angles are equal. So angle B, angle C is equal to, we know that 60 degrees, because all the sides is 60 degrees, all the angles. And ADB, angle ADB is equal to angle ADC. ADB is equal to ADC is equal to 90 degrees. Also we know that AB is equal to AC, equilateral. From this, triangle ABD and ACD are congruent and similar congruent triangles because side is equal, the angle is same, so these two triangles are congruent. That means hence BD is equal to we know that CD is a midpoint, the perpendicular line and midpoint also, that equal to BC by 2 we can write. We know the side is A, so A by 2, BD equal to A by 2. Now triangle ABD, we know that it is a right angle triangle. In this right angle triangle, AB square is equal to hypotenuse square is equal to AD square plus BD square. AD square plus BD square. What is AB? AB is small a. AB equal to, we can write A square is equal to AD. What is AD? AD is H square plus BD. What is BD? A by 2 whole square. A by 2 whole square. But we know that BD is equal to BC by 2, that equal to A by 2. Okay. From this equation, A square is equal to H square plus A by 2 whole square is equal to A square is A square, that equal to H square plus A square by 4. Now H square is equal to A square minus A square by 4. Take this A square by 4 to left side, A square minus A square by 4. Now taking LCM, 4A square minus A square by 4. So 4A square minus A square by 4, that equal to H square is equal to 3A square by 4. Take this 4 to left side, 4H square is equal to 3A square. This is the this is required to prove. PQR in a triangle, right angled at P, and M is a point on QR. M is a point on QR, that the PM is perpendicular to QR, so that PM square is equal to QM into MR. QM into MR. Now in PQR triangle, P is 90 degrees and M is also, that means PM is perpendicular to QR. PM is perpendicular to QR. So RTP required to prove that PM square is equal to QM into MR. Proof. In triangle PQR and MPR, P is equal to M is equal to 90 degrees. P equal to, from PQR, P is equal to 90 degrees. And PMR, M is equal to also 90 degrees. And R is common to PQR and PMR triangle. So with respect to this angle condition, that PQR and PMR both are similar triangles. This is number 1. And in the same way, take PMQ. This is also a right angle triangle. PMQ is also right angle triangle. This is right angle triangle. From this, M is 90 degrees, same P is also 90 degrees, and Q angle is same for PQR triangle and PMQ triangle. From this we can write PMQ Q. Triangle PMQ is similar to triangle PQR. Okay, PMQ is similar to PQR with respect to angle. From PQR and PQ, MPQ, PM is PM and P and M is 90 degrees, Q is common, so that P and M is 90 degrees, Q is common to this PQR and PMQ triangle. So then the PQR and MQP triangles also similar. From 1 and 2, PQR and MPR, MQP are transitive. From transitive property, these both are similar triangles. PQR, MPR and MQR. These three triangles are similar. From this MPR and MQP, we can write from MPR, this is a triangle, and MQP, it is a triangle, and both are similar triangles. From this we can write MP, altitude of this MP PM by MQ is equal to PR by QP, and that equal to MR by MP. So ratios of the corresponding sides of similar triangles are equal. Then PM by, we can write PM by QM, that means MP means PM by QM is equal to MR by PM. So now take this PM to right side, PM into PM is equal to MR into QM. So PM square is equal to QM into MR. ABD is a triangle. ABD is a triangle. Right angle at A, and AC is perpendicular to AD. This is perpendicular to AD. So that AB square is equal to BC into BD, and AC square is equal to BC into DC, and AD square is equal to BD into CD. Now given triangle ABD, at angle A is 90 degrees and AC is perpendicular to BD. This is perpendicular to BD. Given are required to prove AB square is equal to, first one, AB square is equal to BC and BD. Prove in triangle ABD, in triangle ABD, this is the big triangle BAD, and CAB, this is another one, CAB, angle CAB, and BAD is equal to ACD. The angle A is 90 degrees and C is also 90 degrees. So that's why BAD, angle BAD, angle at A is 90 degrees, angle at C is also is equal to angle at BCA is equal to 90 degrees. Then and B is common to ADB, ABD triangle and ABC triangle. So angle B is equal to angle B. Therefore, these two BAD and ABD triangle and this CAB triangle both are similar because angle similarity condition. So similar triangles, then the corresponding sides, ratio of the corresponding sides are equal. Then AB is a side and BC is a side. If you turn this, you will get like this. This is B, this is A, this is C. Angle at C is 90 degrees. Okay, AB. Now observe this. AB, here is BC. AB by BC is equal to BD, hypotenuse. Here is the hypotenuse is AB. BD by AB is equal to, and another side AD by, what is that, AC. Okay, because the two triangles are similar triangles, the adjacent corresponding sides, the ratio of sides is also equal. Yeah, hence AB by BC is equal to BD by AB is equal to AD by AC. The ratio of corresponding sides of similar triangles are equal. From this, AB by BD, take this 2, BD have to take this, and BC take right side. AB by BD is equal to BC by AB. From AB into AB is equal to, and BD into AB into AB is equal to BC into BD. So AB square is equal to BC into BD. AB square is equal to BC into BD. And second one, AC square is equal to, AC square is equal to, we have to prove that BC into CD or DC. From 1 and 2, we proved that ACB and DCA, these two are similar triangles, and ABD is also similar triangle. Already we proved. From this we can write AC by DC is equal to, I will write these two triangles separate. Now observe this, ABC triangle నేను ఇలా రొటేట్ చేశాను, ఇట్లా క్లాక్ వైజ్ ఇలా రొటేట్ చేశాను. అంటే ఏ ఇక్కడికి వచ్చేసింది, అట్లాగే ఈ సి ఇక్కడ ఉండిపోయింది, ఈ బి ఇటువైపు తిరిగింది. అంటే ఎలా ఏర్పడదు, ఈ విధంగా ఏసిబి అని ఏర్పడదు. అట్లాగే ఈ డిసిఏ అనే ట్రయాంగిల్ని, ఈ డిని ఇటు జరిపాను, అప్పుడు ఈ ఏ ఇటు వస్తుంది, అప్పుడు ఏమవుతుంది, ఇలా ఏర్పడుతుంది. ఇది డి, ఇది సిఏ, ఈ విధంగా డిసిఏ ట్రయాంగిల్ ఏర్పడ్డది. ఇప్పుడు ఈ రెండు ట్రయాంగిల్ నుంచి మనము కరెస్పాండింగ్ సైడ్స్ చూసినట్లయితే ఏసీ బై డిసి ఈజ్ ఈక్వల్ టు బీసీ బై ఏసీ అని రాసుకోవచ్చు, ఈజ్ ఈక్వల్ టు ఏబి బై ఏడి అని రాసుకోవచ్చు. ఓకే, ఏసీ బై డిసి, డిసి ఇది డి, ఇది సి, డిసి ఈజ్ ఈక్వల్ టు, ఇది బీసీ, ఇది సిఏ, బీసీ బై సిఏ, పొడవుది ఏబి బై ఏడి, we can write AB by AD. Then from this two, AC by DC is equal to BC by AC, and cross multiply this, AC into AC is equal to BC into DC. AC square is equal to BC into DC. This is the question for answer. And the third question, AD square is equal to BD into CD. AD square is equal to BD into CD. We have to prove that. And this is ABD triangle and CAD triangle we need to take. Now observe these two figures. ABAD is a right angle triangle. This one BAD is right angle triangle. So I just turned here. A is 90 degrees here, and B is here, D is here. And from this ACD triangle is also, I just turned here, ACT. So C is 90 degrees. Now we can, these both are similar triangles, so that we can write the corresponding sides AB by AC is equal to BD by AD and AD by CD. From these two, BD by these two, BD by AD is equal to AD by CD. You can write AD into AD is equal to CD into BD. So AD into AD square is equal to BD into CD. ABC is an isosceles triangle, right angled at C, and prove that AB square is equal to 2AC square. Isosceles means two sides are equal. So here is a right angle. In ABC, angle C is 90 degrees. AC is equal to BC because the two sides are equal, and AB is hypotenuse for this right angle. So we can write with respect to that using Pythagoras theorem, AB square is equal to AC square plus BC square. But what about AC and BC? They both are same. We can write BC equal to AC. Then AB square is equal to AC square plus BC equal to also AC, because BC is equal to AC are given. Then that equal to 2AC square. AB square is equal to 2AC square. Yeah, from ABC, C angle at 90 degrees, AC square is equal to AC square plus BC square is equal to, we know that AB square, squares of the hypotenuse is equal to the sum of the squares of the other two sides. That is Pythagoras theorem. Then AC square plus, then we can write ABC equal to AC. Substitute the value BC equal to AC because isosceles triangle is that AC square plus AC square is equal to AB square. Then AB square equal to 2AC square. O is any point on the interior of a triangle ABC. Interior of a triangle ABC. Then OD is perpendicular. This OD is perpendicular BC, and OE is perpendicular to AC, and OF is also perpendicular to AB. So that OA square is equal to OA square plus OB square plus OC square minus OD square minus OE square minus OE square minus OF square is equal to AF square plus CD square plus CD square, AF square plus BD square plus CA square, AF square plus BD square plus CA square. Given ABC triangle, ABC, it's a ABC triangle. O is an interior point of ABC. This is interior point of ABC, and OD is perpendicular to BC, and OE is perpendicular to AC, and OF is perpendicular to AB. We require to prove that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. Now from this, OAF, now this is the triangle OAF at 90 degrees is at F. So OA is hypotenuse and AB and OF are other two sides. Then we can write OA square is equal to OA square hypotenuse OA square is equal to AF square plus OF square, AF square plus OF square from Pythagoras theorem. Then AF square is equal to, we can write OA square minus, take left side, OF square. This is number 1. And likewise from OBD triangle, and the second triangle is OBD. This is OBD triangle. OB is hypotenuse and BD and OB are the other two sides. We can write OD square plus BD square is equal to OB square. OB square plus is equal to BD square plus OD square. Then BD square is equal to OB square minus OD square, that equal to BD square. This is number 2. And the number 3 is OC square. We need to have this OC, this one triangle, it's a right angle triangle at E. Then OC square is equal to CE square and EO square. So that equal to OC square is equal to CE square plus OE square. Take OE left side, OC square minus OE square is equal to CE square. This is number 3. Adding these 1, 2, 3, we will get OA square minus OF square and OB square minus OD square and OC square minus OE square is equal to AF square plus BD square plus CE square. So that equal to, write in order, OA square plus OB square plus OC square minus OD square minus OF square minus OE square, that equal to AF square plus BD square plus CE square. This is number 4. So our answer is this one. AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. We require to prove this one. From OAE, this is triangle OAE. Here is the right angle. We can, OA is the hypotenuse and other two sides are OE and AE. OA square is equal to AE square plus OE square. This is number 1. And the same, OA minus OE square is equal to AE square. And OBF, from OBF, it is the right angle at F. From this we can write OB square is equal to OF square plus FB square, then OF square plus FB square, OB square is equal to, so FB square is equal to OB square minus OF square. This is number 2. From OCD, OCD. This is another triangle at 90 degrees. OC square is equal to, we can write OD square plus CD square. OD square plus CD square. OD square plus CD square. Then OC square minus OD square is equal to CD square. Number 3. From 1 to 3, adding 1 to 3, we will get OA square minus OE square and OB square minus OF square and OC square minus OD square is equal to AE square plus CD square plus BF square. AE square plus BF square plus CD square. But we know that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to, already we proved in the first theorem, this one, OA square plus OB square plus OC square minus OD square plus OA minus OA square, OE square minus OF square is equal to AF square plus BD square plus CE square. So this is equal to AF square plus BD square plus CD square we can write, and this is equal to AE square plus CD square plus BF square. Hence it is proved. A 24-meter long wire attached to a vertical pole of height 18 meters and it has a stake attached to the other end. How far from the base of the pole should that stake be driven so that the wire will be taut? Yeah, now look at here. The height of the pole is 18 meters. This is 18 meters. And that attached a vertically pole, that is stake, this one, 24 meters. Like a wire, that support wire, like the wire taut, and the pole should be driven to so that wire will be taut. From what is the distance between B and C, we have to find. Now see that height of the pole is AB 18 meters and length of the wire, that is AC, equal to 24 meters. Distance between the pole and the stake B D meters. By the Pythagoras theorem, we can apply hypotenuse square is equal to sum of squares of the two sides, and side square AB square plus BC square. Then hypotenuse is 24 square is equal to, one side is given 18 square and another side, that is D square. Now substitute the values. 24 square is equal to 18 square plus D square. D square is equal to 24 square minus 18 square. 24 square is 576, 18 square is 324. Subtract 576 minus 324, we will get 252. D square is equal to 252. Taking both sides square, square will be cancelled, square root will be cancelled. D is equal to 252 means 36 into 7. 36 is a square number of 6. We can write 6 root 7. D equal to 6 root 7. Two poles of height 6 meters and 11 meters stand on a playground. If the distance between the 4 feet of the pole is 12 meters, find the distance between their tops. Now look at here. Here is a pole. One is 6 meters, another one is total 11 meters. Distance between the two poles is 12 meters. And 12 meters the pole. Find the distance between the top. And now look at here. This is a right angle triangle. DBE is a right angle triangle. BD square is equal to, we can write BE square plus DE square. But this height is 6 meters and this height is also 6 meters. The total height is 11, so 6 and 5 meters. 5 and 12 meters are there. To find the BD square, substituting Pythagoras theorem, we know that BD square is equal to what? Remaining sides, BE square plus DE square. What is BE? Is given, that is 12 square plus DE is 5 square. 12 square is 144. Now look at here. The length of the first pole is AB 6 meters. The length of the second pole is 11 meters. And distance between the folds is 12 meters. Find the ABCD is a rectangular. ABED is a EB is a rectangular, and BED is right angle triangle because angle E equal to 90 degrees and DE is equal to 5 meters because 11 minus 6 equal to 5 meters and BE is equal to 12 meters. Now apply BD square is equal to BE square plus DE square. Hypotenuse square is equal to sum of two side square plus side square. This is the Pythagoras theorem. 12 square and 5 square is equal to 144 plus 5 square is 25. 144 25 is 169. Then BD is equal to under root 169. 169 is square number of 13. So BD equal to 13. The distance between the top of the pole is 15 meters. This is 13 meters. In an equilateral triangle ABC, D is a point on the side BC such that BD equal to 1 by 3 BC, and prove that 9 AD square is equal to 7 AB square. BD is 1 by 3rd of BC. 1 by 3rd of BC. It is given. So that means BC equal to, this is 1, this is 2. DC equal to 2. BC equal to BC. BD is 1 by 3rd. That means it is DC, CD is 2 by 3rd. Now given triangle ABC is an equilateral triangle. Equilateral triangle means ABC, this side, and side is total. Both are same. And the point D is a point on BC such that BD is equal to 1 by 3rd BC is given. Required to prove that 9 AD square is equal to 7 AB square. 9 AD square is equal to 7 AB square. Construction. Draw the median, that is AE, through meeting at BC at E. BC at E. And for that, in AED is a right angle triangle and at E is 90 degrees. Altitude and median the same in the equilateral triangle. So we know that BE is the midpoint, E is the midpoint of BC. Then AD square is equal to, we can write AE square plus DE square. AE square plus DE square. Because it's a right angle triangle, hypotenuse square is equal to side square plus height square. Then AC square is equal to AE square plus CE square. From A is a triangle, AC square is equal to AE square plus CE square. And AE square is equal to, from number 1, AE square is equal to AC square minus CE square. We need AE square, that is AC square minus CE square. AE square is equal to AC square minus CE square. CE means half of BC and half of BC, and also half of AC, half of AC. So we can write this CE is 1 by 2 AC whole square. Okay, half of AC whole square. AC square minus half of AC whole square, that is AE square. Also is AC, BC, AD, AB are all are equal. Also we can write this AE square is equal to AB square. AC means AB square, because we need that AB in terms AB. So 1 by 4 AC square. Okay, AE square is equal to, AC means AB, and this is 1 by 2 AC whole square is 1 by 4 AB square. 1 by 4 AB square. AE square is equal to AB square minus 1 by 2 AB whole square. Then this is equal to AB square minus 1 by 4 AB square. Take LCM, 4 AB square. 4AB square minus AB square is equal to 4 LCM, 4AB square minus AB square. 4AB square minus AB square equal to 3AB square by 4. This is number 2. Okay. AB is equal to AC. From C is equal to 1 by 2 BC. The midpoint kabatti 1 by 2 BC. And now DE is equal to BE minus BD. DE is equal to BE minus BD. What is BE? BE is half of BC. BE is half of BC. We can write this BE is 1 by 2 BC. And BD is already given in the BD is equal to 1 by 3 BC, already given in the question. So substitute that BD value 1 by 3 BC. This BE is 1 by 2 BC. Now 3 is LCM. 3 minus 1 by 3 minus 3 BC minus 2 BC by 6. That equal to LCM is 6. So 3 BC minus 2 BC by 6 is equal to BC by 6 or 1 by 6 BC. We can write DE is equal to 1 by 6 BC. DE is equal to 1 by 6 BC. What is that? DE is equal to 1 by 6 BC. What is BC? BC equal to also BC is equal to AB is equal to AC also. We can write 1 by 6. DE is equal to 1 by 6 AB also, because all the sides are equal in equilateral triangle. So from this second equation, from the second, AE square is equal to 3 by 4 AB square. This is second one. And this is third one. DE is equal to 1 by 6 AB. Squaring both sides, we will write now AE square is equal to, what is that? 3 by 4 AB square This is second one. And the third one is DE means DE whole square is equal to 1 by 6 whole square means 1 by 36, and AB into AB whole square equal to AB square. This is number 3. From 2 and 3, AE square plus DE square is equal to, what is AE square and DE square? Now look at AE square and DE square is equal to AD square. AE square plus AE square plus DE square is equal to AD square. We can write. Substitute the values in this equation. What is the first one? AD square is equal to AE square plus DE square, and AD square is equal to AE square is equal to 3 by 4 AB square, this one, and DE square is equal to 1 by 36 AB square, and 36 is LCM, and taking common AB square, and 4 6 are 4 9s are 36, so 9 3s are 27 plus 1 by 36, that equal to 28 by 36 AB square. AD square is equal to 28 by 36 AB square. Then 4 7s are 4 9s are 36. So then AD square is equal to 7 by 9 AB square, where 9 AD square is equal to 7 AB square. In the given figure, ABC is a triangle. Right angled at B, and D and E are points on BC, trisects it. This is a D and a C are trisect, that means 1 1 1 1 is to 1 is to 1. So then prove that 8 AE square is equal to 3 AC square plus 5 AD square. This is we have to require to prove. Given triangle ABC is a triangle ABC, and B is 90 degrees, and DE are the points and trijection of BC. Then we require to prove 8 AE square is equal to 3 AC square plus 5 AD square. Prove that triangle B, and we know that AC square is equal to AB square plus BC square. This is Pythagoras theorem. Hypotenuse square is equal to remaining square sum of squares of two sides. Then AC square, 3 AC square equal to, multiplying with 3 equal to 3 into AB square plus BC square, 3AB square plus 3BC square. Here BE is equal to 2 by 3 BC, and BD is equal to 1 by 3 BC. You can write this BE is equal to 2 by 3 BC, and BD is equal to 1 by 3 BC. We can substitute the values in the equation. AC square is equal to AB square plus BC square. Then 3AC square is equal to 3AB square plus 3BC square. BC equal to, we can write BC equal to 3 and 2. If we take left side, the denominator changes into numerator and numerator into denominator. 3 by 2 BE we can write BC equal to, and 3AC square is equal to 3AB square plus 9 square is 3 square is 9, 2 square is 4, and 3 multiply 9 times is 27 by 4 BE square. This is equation number 1. And we know that angle B in that ABD triangle, B is 90 degrees. Also we can write AD square. for AD triangle is equal to AD square is equal to BD square plus AB square. We can AD square is equal to AB square plus BD square. AB square AD square is equal to AB square plus BD square. So this one multiplying with 5 AD square is equal to 5 AB square plus 5 BD square. So this BD is equal to, what is BD equal to? We can write 1 by 3 BC or 1 by 2 BE also, 1 by 2 BE. BD is equal to 1 by 2 BE or 1 by 3 BC. Now substitute this value 1 by 2 BE whole square. Then 5 AB square plus 1 by 2 BE square, that means 25 by 2 BE square. No, 5 is outside. 5 into 1 by 2 BE square, that is 5 by 2 BE square only. First one is 3AC square is equal to 3AB square plus 27 by 4 BE square. First the 3AC square is equal to 3AB square plus 27 by 4 BE square. This is number 1. Number 2, 5AD square is equal to 5AB square plus 5 by 4 BE square. This is second. Adding these two, 5AD square and 3AC square plus 5AD square is equal to 5AB square. First 3AC square equal to 3AB square plus 27 by 4 BE square plus this is 5AB square plus 5 by 4 BE square. So now 3AB square plus 5AB square is 8AB square, 27 by 4 BE square, 5 by 4 BE square, that equal to 27 plus 5, 32 by 4 BE square. Then that equal to 4 8s are 32. 4 8s are 32. So that 8 is common. Take 8 is common. AB square plus BE square. We know that AB square plus BE square. AB square plus BE square is equal to AB square. AE square. AB square plus BE square is equal to AE square. This is AB square plus BE square is equal to AE square because here is the right angle. So from this AB square plus BE square is equal to, we can write AE square. Therefore 3AC square plus 5AD square is equal to 8 AE square. ABC is an isosceles triangle or right angled at B. This is ABC triangle, right angle at B. Similar triangles are ACD. This is ACD, similar triangle, and AB is also similar triangle. AB are constructed on sides AC and AB. These two are constructed on side AB and AC. Find the ratio between the areas of AB, E and ACD. Given ABC is a triangle where AB equal to BC, AB equal to BC, AB is equal to BC, and B angle at B is 90 degrees, ABE on AB and AC ACD on AC are equilateral triangles. These two are equilateral triangles. Yes. Let equal sides of the isosceles right triangle AB and BC, AB equal to BC, that equal to say A. This is A and this is also A. We know that we can find that AC square is equal to, and then it is A, it is also A, it is also A, because ABE is a equilateral triangle, and we can find that AC square is equal to A square plus A square, that is 2A square A root 2A. Okay, root 2A, this side is root 2A. Then triangle ABC, B is 90 degrees, AC square is equal to AB square plus BC square, side square, A square plus A square, this is A square, this is A square, and 2A square, AC square is equal to 2A square, that is root 2A, this side. But ABE and ACD are the similar triangles. The area of ABE by ACD is equal to AB square by AC square. AB, the corresponding sides, squares of the corresponding sides ratio is equal to area of the two triangles ratio. So this is equal to ABE is equal to, we know that ABE is a right angle triangle, that is AB square is A square and AC square is equal to root 2A square, AC is equal to 2A square, that equal to 1 by 2. Okay, that equal to 1 by 2. Therefore, the area of ABE and ACD ratio is 1:2. Equilateral triangle are drawn on the three sides of a triangle, a right angle triangle, so that the area of the triangle on the hypotenuse is equal to the sum of the areas of triangles on the other two sides. And here is drawn that here is ABCD is a right angle triangle, and AC side, its hypotenuse side, is drawn a triangle, equilateral triangle, and AB side also drawn a equilateral triangle, and BC side is also drawn a equilateral triangle. Now the AC side is equal to AR and RC, AC equal, and AP, PB and AB also equal, BC and BD and DC also equal. Given a right angle triangle ABC with right angle at B, equilateral triangles PAB, QB, this is Q, QBC and RAC are described on sides AB, BC and CA respectively. We require to prove that triangle, area of the triangle BCQ is equal to BCQ plus area of the triangle ABP is equal to the area of the triangle ARC. Now proof AB square plus BC square is equal to, we know that AC square, because it's a right angle triangle ABC. So the hypotenuse is AC square, so remaining sides are AB and BC, so AB square plus BC square is equal to AC square. But APB and BQC, ARC, these three triangles are similar. Areas of the similar triangles proportional to the squares of the corresponding sides. Now APB by BCQ the area of these two triangles, area of A, P, B by B, C, Q is equal to, we can write AB square, corresponding sides are AB and BC. So AB square by BC square we can write. APB by BQC triangle. These two triangles are similar, so the corresponding sides AB and BC are the corresponding sides. The area of these two triangles ratio is equal to AB square by BC square. And also we can write, and similarly BCQ and ARC area of this ratio is equal to triangle BCQ by triangle ARC is equal to, BCQ means BC side, BC square by AC square also equal. Unlike ARC and APB is also AC by AB, AC square by AB square we can write. Now the first one, APB by BCQ is equal to AB square by BC square, AB square BC square, and the second one, BCQ by ARC is equal to BC square by AC square, BCQ by ARC is equal to BC square by AC square, and third one, ABP area by ARC area is equal to AB square by AC square. ABP by ARC is equal to AB square by AC square. These three. By adding 2 and 3, BC square, AB square, we know that AC square is equal to AB square plus BC square. Like we are adding these two, BCQ by ARC triangle ARC area of triangle ARC plus ABP by ARC is equal to BC square by AC square plus AB square by AC square. This is AC is common, AC square is LCM. So we can write BC square plus AB square. But we know that BC square plus AB square in the ABC right angle triangle ABC, that BC square plus AC square is equal to, we can write this is AC square. So that AC square by AC square become cancelled. So that BC square plus AB square is equal to, we can write that AC square by AC square. Okay, AC square, AC square cancelled. Here also ARC triangle area ARC is also common. So BCQ plus triangle ABP by triangle ARC is equal to ARC AC square cancelled. That equal to 1. Now take this right side. BCQ plus triangle ABP is equal to triangle ARC area. Prove that the area of the equilateral triangle described on the sides of a square is of the area of the equilateral triangles described on its diagonal. Now given that A square ABCD, the square ABCD and ADP have been described on side AB. ADP have been described on AB, that is equilateral triangle, and ACQ is and ADP ACQ is on AC diagonal, AB and diagonal AC respectively. We need to find this area APB D and ACQ. ABCD is a square. It is a diagonal, and if you take 1, this is root 2. RTP, APD area is equal to 1 by 2 of ACQ area, half of this area. So then this we need to prove triangle APD and triangle ACQ are similar with respect to angle. APD, ACQ are similar triangles. Then that ratios of APD ratio and ACQ area of this APD and ACQ ratios are their corresponding sides. What are the corresponding sides? That APD is AD and ACQ is AC. We can write that area of APD by area of ACQ is equal to the corresponding sides are AD square by AC square. This is AD corresponding side to APD and AC is the corresponding side to ACQ. We can write AB square AD square by AC square on this. APD by ACQ equal to AD square by AC square. This is number 1. From ADC triangle, we know that it is a right angle triangle. AC square is equal to AD square plus CD square. We can write from ADC triangle AD square plus DC square is equal to AC square from Pythagoras theorem. But we know that AD square plus AD square is equal to AC square. Why? The square, all the sides are equal. So AB, AD and DC, both sides are equal. We can write AD square plus AD square that equal to AC square. Now observe this. AD is equal to CD. This is a square. We can write AD is equal to CD or DC. So AD square plus AD square is equal to AC square. 2AD square is equal to AC square. Substitute this value to AD square, AC square is equal to 2AD square in the equation. APD by ACQ is equal to AD square by 2AD square. AC square equal to 2AD square. Then AC square is equal to, we know, 2AD square. 2AD square. So AD square cancelled. This equal to 1 by 2. APD, the area of APD is equal to 1 by 2 into ACQ. Therefore, the ACQ area is half of APD area is half of ACQ area.